Yeah, so I'm going to talk today about how we use machine learning at Quora. And as you heard in the introduction, I've worked at several other companies before. Previously, I was at Netflix, and I was leading the team working on the famous recommendation algorithms at Netflix. And I think I've written a lot about what we did at Netflix and how we thought about optimizing machine learning algorithms and using data for actually improving the product. So what I'm going to do today is I'm going to walk you through the same story, but for a very different company. And I think some of the use cases that I'm going to be illustrating today about Quora are going to help you understand, like, how does a company think about using machine learning and data for something that actually matters, which is improving the product and making your users happy, right? So first of all, let me have a quick show of hands. How many of you are Quora users, so you know what Quora is and how it works like? OK, maybe half of you. I'm going to just quickly introduce you to, for the other half, to what Quora is or what how we think of ourselves, because even users sometimes don't think of ourselves the way we do. So our mission is to share and, very importantly, to also grow the world's knowledge, right? So in order to do that, we want to create knowledge through questions and answers, and also other vehicles, but mostly question and answers. And we do have millions of questions and answers already in the site. We have millions of users, thousands of topics. And the idea, it's kind of like, if you think about it, growing organically a knowledge base like Wikipedia, but also making it entertaining and making it useful at the same time. So what that means really is that we care about 3 different dimensions. And I think that's where, when you start to think about, like, what's the core business and the mission of the product and the company, but also what are the different dimensions that go into the business and the mission, and how do you optimize them? It's when you start thinking about what you're going to be doing with your data and your algorithms, right? So the 3 dimensions we care about a lot in Quora are relevance, quality, and demand. And they need to all go hand in hand, otherwise Quora will not be successful. And that's different for every business, right? So you might have different dimensions that you care about. You might just care about relevance because you're like, OK, I'm targeting advertising to somebody, and all I care is they click on the ad. The rest doesn't matter. I don't care. I could care less about the quality. If you have a different kind of business, you'll say, I will only care about quality. If you're Wikipedia, for example, it's like, really, I don't care about relevance. I don't even care too much about demand. I just care about having the best article out there. But we care about these 3 things, right? So quality, we want to have good quality. We want to have knowledge. We don't want jokes, memes, things like that in the product. Relevance, we want to make sure the right knowledge gets to the right person. And demand, because we also care about answering the questions that most people have. Of course, we also care about niche knowledge, but we mostly care about what most people want to know. So we take those dimensions, and then we look at the data and say, OK, how can we generate, how can we turn the data into this kind of objective function that we're going to be optimizing for? So this is more or less how our data ecosystem looks. And basically, we have users, we have questions, we have answers, we have topics, and then we have different actions. I simplify by saying we have upvote and downvote. We have different actions that users can take on answers and questions. So there's different relations that you can see here. Like, for example, users can endorse other users, or they can follow other users. Users can write answers. They can write questions. Users can also upvote and downvote, or they can want answers on questions. They can follow topics also, and then answers, obviously questions have answers, and answers have upvotes, and questions have upvotes and downvotes, and questions have topics. So bottom line, this is a pretty intricate and complex ecosystem of data types and data relations. You can think about it like it's a knowledge base with an added layer of a social network on top of it. And there's also sort of like topical relevance added to all of this, right? So we look at all of this and say, well, this is a very rich ecosystem of data. And what can we do with it? The first thing we can do with it is stare at it and basically learn from the system. And that's what some of our data scientists do. These are two examples. I'm not going to go into the details. You can actually read about it in our data blog. So Shankar, for example, studied the propagation effects of mostly upvotes and downvotes in the network from a complex network perspective. And this is a very long, very interesting, if you're interested in sort of like network dynamics and complex networks, how do the upvotes and downvotes propagate in a system like this? So we want to understand what's going on in the network, and then we want to, if it's wrong, we want to fix it, or if it's great, we want to leverage it to make the product better, right? Another example, so Don here also writes about the importance of topics and semantics and how the different topic network, which is a different kind of network, actually how the hierarchy of topics that we have, the ontology, how the different topics relate to each other, how they also relate to users that are following them, and so on. And all of that, again, helps to sort of like inform what are the product decisions that we're going to be taking. OK, so we've heard about the mission of the company, how the different dimensions that we're trying to optimize, took a look at the data that we have. Now let's get into how do we turn that into machine learning solutions for the product. So I'll give you a couple of examples, and you'll start seeing a pattern of like how do I think generally about turning this data plus machine learning algorithms into solutions for the product. So the first example is ranking, and particularly answer ranking. So given a question in Quora, we're going to have several answers, and we want to rank those answers in a way that we have the best answer at the top, and the quality degrades as you go down. Now, of course, the problem here is, what does best mean? What's a good quality answer? How do we define that? And there's not a unique answer to that question. It's like, it really depends how do you define your business, and that's what's going to define your success or your failure. In our case, we have a definition of what a good answer means at Quora. Actually, it's public because we're telling our users what it is. So you can go in Quora and read, OK, what is a good answer for Quora? And we'll tell you things like, you know, an answer needs to be truthful, it needs to be reusable, it needs to provide explanations, it needs to be well-formatted, and so on and so forth. This is something that is not defined by engineers or even data scientists, right? This is like really the core of the product team and the authors relation team sat down and say, this is what we think a good answer, a good quality answer is. Now, what do we do as data scientists and machine learning engineers? Well, we turn that definition into something that we can optimize for, right? So basically, we translate those dimensions into features. So we're going to be using things like the text itself in order to analyze and figure out, like, how do we come up with features that relate to the text that are going to be telling us how good the text is. We're going to have interaction features like upvotes, downvotes, clicks, what other users are saying or are doing with that answer that is also going to inform. And we're also going to be using things like user features, the expertise in the topic from a given user, right? If we're talking about an answer on data scientists, yes, and the person who's writing that answer we know is a famous data scientist or has been endorsed by other data scientists, we're going to give more credit to that. But it's not we, as the product designers, are going to push giving more credit to people that know about data scientists. We're going to feed that into the model, and we're going to let the model learn itself whether textual features, interaction features, user features, what is it that really matters, right? So basically, you have to define, obviously, the tricky thing here is you have to define a training set, you have to define what is a positive label, what is a negative label, and then optimize your ranking algorithm for that, and let the model learn what are the features that are useful for you. Another example, yet another ranking example, is feed. So feed is what you actually see when you go to your homepage or when you open your app on your mobile device. That's the first thing that you'll see, and that's sort of like the window into the Quora world. So we want to make sure that that's engaging. There needs to be personalized relevance there. We want to make sure the things you get are good quality, but are also things that you like. And basically, we define interesting as the addition of several things. The topical relevance, the social relevance, so is like, was this written by a friend? Was this upvoted by somebody that you trust? and the timeliness. Is this something that is recent and it's timely and you want to know about it? So all those things need to go in there. Another interesting aspect is in the feed, we optimize two different kinds of things. So we call them stories, but story is actually a concept that includes both questions and answers. That actually makes it a pretty interesting problem, because now we're not only optimizing your feed for the probability that you like an answer, but also we're adding the probability that you actually answer a question. So both things actually go into we're optimizing. From the machine learning perspective, we use a personalized learning to rank approach. I'll say a couple things about models later, but there are several approaches you can take here. And obviously, when we test the machine learning approach versus just a time order feed, we have huge gains in engagement, and that's good for the product. There are several challenges, like we have many candidate stories. We need real-time ranking because we care about timeliness. And we also, as I said, optimize for personalized relevance. So again, what we look at here is what's the data that we have. So in this case, these are the different elements that you will see in your feed. And all of them are actually actions that the user can take on either answers or questions. So a user can click on a question, they can upvote, they can downvote, they can comment, they can share, they can expand. They can do all these things, and all these things, you can actually use them and treat them either as features or either as examples that you will be considering, positive or negative, then when you're optimizing your machine learning model. And of course, a key thing here is like, okay, how do we define our objective function? How do we define what is relevant? And what is relevant could be defined as a sum of different actions and different weights for the different actions. And that's, I mean, maybe an untold story of sort of like secret sauce of every company that you can think of that is actually doing optimization on user-facing machine learning models using data. Is like you need to come up with your definition of what your target is and what you define that you want to optimize for. And in this case, you can take all the different actions here, and you can do a bunch of things. And I'm not going to say which ones are good or bad, but you could say, OK, what I'm going to do is I'm going to minimize the number of downvotes, or I'm going to maximize the number of upvotes and shares plus expands, or I'm going to combine them in a different way and find different weights for each of these actions. And that's what I really care for. What you really care for is the result of your A/B test, just to be clear. The thing is, how do you map this particular function into your A/B test is what you need to find in the lab and what you're going to be iterating on to try to find what those weights make the best result on your A/B test. OK, once you have that, you can do two things. You can predict the final value directly. That's kind of like tricky because, I mean, it's a single regression model, if you will, but the problem is you have a lot of things that are coupled there, and it's hard to do all at once. The other thing you can do is predict the probability of each of the actions and then combine them in a kind of ensemble by just computing the expected value of the addition of all of them. And you need one different classifier or ranking function per action, but it's easier to combine and because you're decoupling the different models from the different actions. OK, and of course, as I said before, feature engineering is essential here. You need to look at the set of features, user-related features like the age, the country, the recent activity, the same for the story, popularity, trendiness, quality, and then interactions between both things, between the user and the story. OK, so as I said before, when you're doing any kind of like learning to rank, there's different approaches that you can take, from using a binary a linear classifier, say logistic regression and so on. That gets you a long way, and there's a lot of things that you can do with that. If you go into sort of like more complicated models, quote unquote complicated, you can go into sort of like decision trees and tree ensembles. As we know, things like GBMs, gradient boosted machines, or gradient boosted decision trees, or random forest. These are models that can be used for classification and regression, but they can also be used for ranking. And actually, variations of those, like lambda mart, are pretty good, and they're known to be very good for sort of like learning to rank approaches. We use, in our case, in-house C++ training code for this particular model, but we also use a lot of like third parties, open source libraries for different models. Okay, I'm going to skip this because I'm running out of time. We do a lot of other machine learning models. So I basically mentioned two ranking approaches. One, which was the answer ranking, which was just an unpersonalized quality ranking, and the second one, which is feed ranking. But we have a ton of other things that we do with machine learning. For example, we recommend topics. Given a user, and given the different topics that the user is following, we're going to recommend new topics. And hey, maybe you're interested in following tips and hacks for whatever, or mental health, or thermodynamics. We have a model that actually optimizes and makes those recommendations based not only on what you follow, but based on users you follow and the interactions you're having with questions and answers from those different topics. We also recommend users. So this is like the who to follow recommendation that LinkedIn, Facebook, Twitter have. We also have it in Quora, and that's also based on things like other users you follow, but in our case, topics that you're following or are interested on, and interactions you're having with users and user-related features. Related questions, another machine learning model. So basically, the idea here is, given your interest in a question, what other questions could you be interested on? And this is, it's a very hard topic. I'm not going to go into the details, because people usually try to approach this from a purely sort of objective similarity function kind of approach, and it usually doesn't work. The fact of the matter, if you're looking at a given, and that's the same for Quora as it was for Netflix or for many other companies, if you're looking at one particular question, you're unlikely to follow up with a very similar one, except if that similar one is higher quality or is more interesting. The problem now is that you need to add things like quality and interestingness into the mix. So it's not only about similarity, it's about adding those things. And you need to take into account things like co-visits and relation of topics and so on in order to optimize your related model. Duplicate questions is an extreme form of that, but again, it's tricky, because in duplicate questions for us, they're bad, they're evil, and we want to kill duplicate questions. So it's different from related questions, which are good, and we really like them, and we want to encourage them. So duplicate questions mean like we're going to have different people answering the same thing on two questions, and we're not going to be aggregating knowledge in the same page. So we want to make sure we kind of kill them. And we have a binary classifier that is trained with labeled data that is identifying those duplicate questions, and needs to work in real time, because we're basically, when you're trying to add another question to the system, we're going to be telling you, hey, are you sure you don't mean this? Because this looks very similar to other things that we have in the system. User trust and expertise inference, that's something I mentioned in feed, for example, that we're using. That's a model in itself, right? That's also an important lesson, is you're going to have models, machine learning models, that learn things that are useful on their own, but they're also being used as input or features to other models. And this is a clear example. Trust and expertise for a given user is going to be transferred. It's going to be used as features for some other models. We want to know whether you are trustworthy in a given topic, say machine learning. And we use your answers that you've written on the topic, the upvotes and downvotes that you got on those answers, the endorsements you got from people that we also know. So it's a network propagation model, which basically transfers this sort of like trust through the network. Think of PageRank, but in the context of social networks. Trending topics, another machine learning model that we use. Spam detection and moderation. This is a huge area for us. Of course, we live out of user-generated content, and user-generated content is usually great, but it can also lead to sort of like having spam and harassment and different things going in. We do have a system that is mostly based on having moderators, so it's a bunch of people that actually work for Quora and end up checking things and saying, yeah, this is bad, we should remove it. But of course, we need to have machine learning algorithms that feed into those moderators. We want to make sure that the better the algorithms is, the less work we're going to be giving to those manual curators. So we're constantly improving those algorithms and making sure that they not only detect whether it's spam or not, but they also output a probability or at least a ranking of like how important is it that the moderator gets to this answer, to this question, or to this user next, right? So we're not only, it's not a first in, first out queue that goes to the moderators. It's ranked by importance and by probability that that thing is bad. Content creation prediction, as I said in feed, we are interested in understanding how likely you are to answer a question. And that's another model that we have. This model actually, again, is used in different parts of the product. For example, we have a particular feature of the product that is called A2A, Ask to Answer. There's a long blog post. The last blog post I think we had in our engineering blog was specifically about how does this model work. But what we're trying to do is like answer the question, what's the probability that you answer this given question with a good answer? And basically, I've sort of like to recap. I went through the dimensions we care about. I talked about the different data that we have, the data ecosystem, and how we analyze and how we study it. And then I went to different product solutions that are trying to optimize different things, different aspects of the product by using the data and the machine learning models. To the question of like what machine learning models are used in production, I mentioned a couple when I was talking about feed, but we use, as I said, many more. And this is sort of like pretty complete, but I think I might be missing some of the models that are currently in production. And they start with logistic regression, elastic nets, gradient boosted decision trees, and random forest, deep neural nets, lambda mart, matrix factorization, LDA, and other non-supervised approaches. So we don't, I always say this, like, I don't put this slide up to sort of like brag about like how many models we know and how good we are about using different models. But the reality is, sometimes if you have the right infrastructure in place, you basically try different models, and it turns out that some work better than others, and it's even hard to say why. Actually, I answered a Quora question last night about when should you use a random forest instead of a GBM, and the typical answer is never, because generally speaking, a gradient boosted decision tree is going to perform better than a random forest, but that's not really always true. As a matter of fact, random forest, first of all, they have less hyperparameters, so they're easier to tune. And you can get away with sort of like just plugging them and play, and they'll work. But besides that, I've also seen in sort of like practical applications that, don't ask me why, but you know, the random forest actually work better than the GBDT. So why not? If you have the flexibility of actually plugging one or the other, that's a good thing. And sometimes we just have different models just because they work better. And we are trying always to optimize different models and using the one that works the best. OK, so I also mentioned that we do extensive A/B testing, and we have different layers for different parts of the systems. And that's how we actually optimize our objective function or our target metric. And we define them according to how much they impact the results of our A/B test. OK, so I'm going to finish here. As I said during the talk, at Quora, we not only have big data, we have also rich, complex data. And our algorithms need to understand and optimize interesting aspects such as quality, interestingness, user expertise, things like that. So not only CTR optimization. We also believe that ML is really key to our success, or we're really investing on it. And we have many interesting problems. Some of them are just half solved. If you go to your Quora account now and you look at it, you'll say, well, Xavier was telling us that they're doing this, but it's not perfect. Yeah, I agree with you. Some things are not perfect. We're actually improving them every single day. So that's why it's actually fun to work in these things. OK, thank you.
And we have time for a few questions and answers. There you go.
Hi. So what approaches do you use to minimize the manual moderation of answers?
Sorry, can you repeat that again? What do we use to minimize the...
Manual moderation of answers.
The manual moderation?
Yes.
Oh, you mean when I was describing the spam attacks, harassment, sort of like jokes and things like that. So there are many things that we do in the product to do these kind of things. One of them is sort of like make it clear through how the product works that it's useless to try to trick the product, right? So for example, there's a well-known feature in the product that is called answer collapsing, which basically, if you write an answer that is bad enough and our algorithms detect that it's bad enough, it's going to be collapsed by default, so nobody's going to see it. We need to be pretty sure that that's the case, because otherwise, if you're a user, you'll get pissed if we're collapsing something that is not good, and then you'll complain, and we'll need to have a moderator go and check whether it's right. But the point is, by enforcing sort of like the right mindset on users, we are telling them like, hey, don't try to add spam or try to put here something that is bad quality, because it's not even going to make it through the system. And yes, sometimes we might be a little bit harsh, and we kind of like have moderation issues that are the other way around. Rather than something that we think it's bad, it's something that our algorithms actually collapse or they just killed, and the user complains, and we need to send a moderator and say, yeah, well, maybe the algorithm was a little bit harsh here. This is OK. It should be good. The point is, that's another interesting thing. For this kind of algorithms, you have to set the right threshold or the right parameters to make the trade-off between precision and recall. That's always an issue in any classifier. But in this case, like, OK, what do you prefer? Do you prefer to let things flow through the system and have the moderators sort of like check the bad stuff, or the other way around? Do you want to have sort of like high recall and not so good precision? And some users are going to get mad and they're going to complain, but then that's when you have the moderators coming in. So that's a product decision. And it's interesting, and I think that's what makes part of this, making this job fun, is that you're really tuning algorithms to whatever the product decision is, and you're changing both at the same time.
Kevin, right behind you.
Hi. I have a question about the training labels that you generate. So a lot of the algorithms you defined were supervised based. So do you guys always have a manual effort going in and training the labels, or you have some kind of automated effort of generating the training labels for the data?
Yeah, good question. So many of the models that I talked about are actually supervised. There's sort of like unsupervised methods that we use, like LDA and say matrix factorization and so on, that also feed into those models. But the reality is most of them need labels. So the question is, what do you use as labels? For many of them, you use user feedback as labels, right? That's what you use. That's what I was mentioning before, like when you combine the different actions that the users say and you say, OK, I'm going to treat those as positive, I'm going to treat this as negative, you're actually using them as labels. However, in some other cases, you are going to need, or you want to have some sort of like ground truth that needs to be manually labeled, and you're going to have to go. For example, a good example of this is the moderation case that we were discussing before. Like, what is harassment? Well, I mean, it's very hard to sort of like define the good and bad examples from user feedback, although you do get some of that, right? You're going to get reports on like, hey, this was harassment, which you can use. Furthermore, you're going to get the moderators at the end deciding, oh, yeah, this was harassment, this was not harassment. That's going to be a decision, but it's also labeled, and then you can feed back into your system, right? So the answer is we use a combination of sort of like manually label. Some of them are high-quality labels that we need to generate and pay for, but then we propagate those high-quality labels through lesser quality labels that go through contractors all the way through to user feedback. And the key thing is like, how do you propagate those labels in those different levels of quality? But there's ways you can do that.
All right, time for one last question, right up there.
Hi. Well, on an average, what is the rough shelf life of each of the models that you have for the various use cases that you showed here?
Sorry, what is the graph?
What is the average shelf life? Like, how frequently do you have to revisit your models or retrain them when you think they might be outdated?
Yeah.
Thank you.
So in most of the models, we really care about timeliness, as I was saying.
Yep.
So we do retrain them very often. I think I'm trying to think, in most cases, and actually my experience in general is like, if you have a way to retrain your models that is not very costly, why not do it? It's generally going to improve the accuracy of your predictions, just for a very simple reason. It's like, just if one feature changes its distribution a little bit from day to day or from week to week, you're better off adapting sort of like the split on your decision tree or the weights on your logistic regression. So the answer is we update them frequently and we retrain them, and that's a good thing. I mean, the only thing, you need to have the system in place that makes sure that when you're retraining, you're actually getting a good candidate of the model, and you need to be able to optimize your hyperparameters every time, and you need to be able to make sure that if the model that is trained is bad for whatever reason, you don't roll it out. But once you have that system in place, which you only implement once, then you can really pretty easily run it on most of your models. Some of them might not need it more than once a week, but generally, if you do it daily, that's a good thing.
We got one last question.
I've noticed sometimes on Quora, sometimes the best answer to a question might be an image, and you're not allowed just to put an image as an answer. And I assume that's because there would be difficulties sort of assessing the quality of that image as an answer. Can you talk about that at all?
Yeah, it's a good thing. I think in a good question. I think in this particular case, it's correct that it would be harder to sort of like detect sort of whether the image is answering the question with some algorithms. But there's good automatic techniques to image quality and image understanding right now that I think we could get closer to having something like that. The reality is you're not allowed to answer a question with a picture because that's a product decision. So it's not a machine learning algorithmic decision. It's mostly there's sort of like this concern, which I think it's true, that answering only with an image leads a lot to sort of like memes, jokes, and things like that. And therefore, it's easier to just cut it out as it is rather than just going into the question of like, was this image good, or how well did the image answer the question? So it's a product decision. At some point that might change, and then we might, for the same reason that we don't allow a video could also answer a question, but the product doesn't, because of a product decision, doesn't decide that that's a good way to go and a scalable way to sort of like generate knowledge.
Thank you.
Thank you.
Thank you. Warm round of applause for Xavier again. Thank you.